Hello everyone, welcome to Coffee with Caleffi. This is Mark Olson. Today we will be reviewing the line of manifolds from Caleffi. Our presentation is about 60 minutes today, quite a few slides and a lot of updated information for those that are already familiar with our manifold line. So we're going to jump right into it. We have so much information here we won't be able to take questions as we go along, but please send them in by way of the chat or the question feature on the GoToWebinar screen in front of you. Okay, manifolds, collecting manifolds. Let's move on. Our training here today is based off of our series of hydronic design journals called Hydronics. Specifically today we'll be talking about manifolds, which is the topic for our edition number 4. So if you haven't seen that edition, please look online. We make it available in PDF form. They're also available in hard copy form with a free subscription that you can sign up for online. And coming soon in the mid part of 2010, for those that have the first 6, is our number 7, which we'll be talking about mixing. Okay, Caleffi manifolds. We've been making manifolds for quite some time. Here's call it a glamour shot of one of our manifolds, our high runner manifolds, our S1 manifold. We'll come back to the slide here in a second, but there's many people in the marketplace up in Canada and the United States that are familiar with Caleffi and may be familiar with this company called IPEX. Under the WARMRITE brand, they marketed a number of manifold products, including this one, and Caleffi was the provider of the manifolds as you see here for IPEX. Back in 2008, IPEX exited the Hydronics business to concentrate on their core technology. So a little bit of tidbit for those that might not have otherwise known that. Okay, what's different about Caleffi manifolds? There's a lot of people in the marketplace making manifolds. It's really our engineering, very detailed engineering, and we'll get into that in a second. But also our production. Our manifolds are made in Italy, and not too much labor goes into our manifolds, as evidenced here by a robot. In this particular process, one of the supply side of our manifolds is coming off a test bench. The robot is going to, if it passes the pressure decay testing, put it over on that conveyor belt off into the background and pick up another manifold to do the same. So for any folks that have come to see our plants in the past, they've seen this before. We're very proud of it. In fact, we make a lot of brass products, not just the manifolds, and here's another shot of the conveyor belt with the manifolds coming down the line. But in general, Caleffi is a producer of a lot of brass control products, enough annually to build 2 Eiffel Towers. So if you've been over to Paris and have an appreciation for how large those buildings are, that building is, you have a good idea as to the scale of our production. Now, manifolds often are tied into radiant systems. It's interesting looking back in time. This is a photo right out of our Hydronics journal number 4, probably circa 1940 or so. This contractor is installing some pretty thick manifold tubes in this slab, or will-be slab. Times have changed and the technology has changed. Can you imagine how he would manifold those into a common header? That would have been interesting. So let's talk about manifolds. What does a manifold do? Well, at its essence, a manifold has some type of flow coming in one side. The other side would typically be capped off, and that flow gets distributed into smaller streams, if you will. In this case, by red, we're indicating hot fluid coming into the manifold and getting distributed out. And that distributed fluid would come back around and either give up heat to emitters, or if it's chillers, would pick up heat, come into another manifold on the collection side, and take that fluid back to perhaps a pump. So a distribution side and a collection side. It's interesting, here in Canada and the United States, we refer to the pair of manifolds as distribution manifolds, and by comparison, in Italy, our colleagues would call this the collettori di distribuzione manifold, so making reference to both the collection side of the manifold and the distribution side of the manifold. So if nothing else during this webinar, you can at least say you picked up a little bit of Italian along the way. So let's move along here. Some photographs of manifolds, starting off with this shot from Magna Steel out east. Looks like a large radiant zone getting installed. There's actually two sets of manifolds. You can see in the foreground, looks like a supply side of the manifold here, quite a few loops, perhaps up to 20 loops. The diameter of that manifold header might be 2-3 inches, so a lot of flow. And this would be the matching return side down here. And then a similar type of manifold set off in the background. This manifold is made out of copper. Moving along, another shot just to get a feel for manifolds. Here's looks like the evidence of similar work, perhaps the same contractor, but two side-by-side manifolds with a similar type of arrangement concerning the supply and return side. So basically, these manifolds are meant basically to simply take fluid, distribute it out, collect it, and send it out. A little bit of a smaller manifold, but similarly a copper manifold, courtesy of Able Distributors in Chicago. This manifold has a little bit more functionality going on. You can see some ball valves and a T over here with it looks like one of our air vents, a Caleffi air vent, fill and purge lines over on the right-hand side, and several different types of PEX and aluminum PEX and different types of connection methods. Interesting to note the Caleffi zone valves off to the left down there. More manifolds. This is a set of two manifolds. On the bottom is a fairly large manifold, looks like about 11 different ports. And I would hazard to guess this is in the basement somewhere because on the return side of this manifold, return evidenced by that blue shutoff valve here, the cooler fluid coming back, sweeping back around and perhaps going upstairs or perhaps into the ceiling to heat a zone. And then up above here, we see a two-port manifold, perhaps going into a small zone, smaller zone to be heated on a different control scheme. You got a zone valve up here and a zone valve up here for each set of manifolds. Moving a little closer to Caleffi product, here is a shot of a manifold and looks like a basement getting constructed, and you can see the 4 loops coming off here. So this is in process of being constructed. Interesting to see this tubing right here. I'm not sure what that is. We don't have the credit on this photo identified. Perhaps that's part of a radon system or what have you, or anti-radon. Caleffi manifold systems here. This is in the Chicago area. Looks like a 6-port manifold and quite a few zones here. So this contractor may be in the process of putting telestats or Caleffi zone valves on the return side of this manifold. We'll see probably in a few slides. Another Caleffi manifold out east in Utah. Now we've been showing these manifolds of Caleffis with different types of PEX, and in this case we got white PEX. Here we have orange PEX. We've seen yellow PEX, and the next slide here is a different type of PEX. And the reason for that is because Caleffi doesn't make PEX, we make manifolds. And so why is it that many contractors choose Caleffi manifolds, given that we don't make PEX? And we'll get into that as to why here in just a couple more slides. Finishing out a couple more shots of Caleffi manifolds off to the left here, you can see another set of Caleffi manifolds. Again, now this with green PEX, courtesy of Montana Radiant out west. Here's not a photo, but a shot of a manifold off in the foreground here, manifold assembly. And this time, instead of sending heat to into a radiantly heated zone, it would be into a panel radiator zone. So much like this could be referred to as a home run distribution method, where it doesn't have to be radiant. It could be a panel radiator or a classic radiator, mid-temperature or high temperature. This perhaps could be 160 degrees. It's taking heat in at that level. And here's some shots of those type of radiators. You can see down below on this photograph, PEX coming in and PEX coming out, PEX having originated from a manifold. Here's a close-up shot of that. And a similar setup taken from one of our Hydronics design journals. And another shot here of a contractor based out of Wisconsin, DS Design Consultants. Now this is a Caleffi manifold assembly. Now what's different about this? Well, it's upside down. He's flipped over the manifolds because he's in a basement, and he has a staple-up heating system. And so instead of routing the manifold to come down, curve around, and go back up like we saw in an earlier slide, he's flipped the manifold supply and return side and just gone straight up. Now, we typically would advise a contractor to be careful about this when they're using a zone valve to control flow. And here this contractor is about to assemble Caleffi zone valves onto the return side of the manifold. And typically, as a rule of thumb, you don't want to have electric underneath fluid, but we know this contractor is very good, and as long as he has those connections very tight, he's probably in good shape here. But as a rule, you want to be careful to make sure those connections are very tight and secure, so you don't have any chance of, over time, leakage of fluid going down into those telestats and causing them to basically short out. Okay, we mentioned Caleffi does not make PEX. This is a lot of different PEX out in the marketplace, and the people that make PEX often also have manifolds. So why is it that Caleffi contractors are choosing Caleffi manifolds? We sell a lot of manifolds, and you can see a lot of these brands here in the marketplace are familiar to you, very good brands, mind you. Well, the reason why is really the key is in the engineering of the fittings. And here's a contractor connecting what looks like a WARMRITE brand PEX, aluminum PEX, up to the Caleffi manifold. And so what did Caleffi do in developing the manifolds? Well, we had to do our fittings from a universal design standpoint. In North America and U.S., 99.9% of all PEX abides by the ASTM standards for PEX, F876, as you can see here, or if they're using PEX, aluminum PEX, multi-layer PEX, if you will, ASTM F1281. And the tolerances that ASTM gives or allows, you can see here, allows for slight differences between different brands. So brand A might run their ID and OD on one side of the tolerance and brand B on the other side of the tolerance, and they'll design their fittings to match that. So when Caleffi designed our universal fittings, we had to take in consideration a universal design that could accommodate all those slight dimensional differences. So how did we do that? Well, here's a close-up of our manifold fittings, and it just let you know what the lay of the land is here. This is the bottom of one of our manifolds. This is the port coming out of it. Notice it's all one piece here. There's no welding. This is all cast and machined product. And down in the white indicates the PEX, okay? And everything else is our fittings, 3 pieces. Top part here is the nipple. Middle part in blue is the bushing, and the bottom part is the nut. So the contractor would basically, the process, he'd put the nut over the PEX, the bush following the nut, and then lastly take this nipple and push it down into the PEX. First point of detail, O-rings. These 2 O-rings are designed in such a way that they will always create an interference fit on the ID of the different brands of PEX out there, creating a nice snug contact. As he pushes that down, the fitting down, the nipple down into the PEX, he creates an interference fit, 2 O-rings. Another point of detail is these little serrated edges here around the circumference. As this nut gets pushed on and starts to screw down onto the manifold, the bushing starts to squeeze and contract, and you can see these little notches are basically contraction spaces so that it can get smaller and smaller in diameter. And as it contracts, it creates a nice tight seal around those O-rings, and it actually grips onto these little knurls, preventing the PEX from being able to get pulled off. And then lastly, up here you can see this is actually a chamfer. This is a 45-degree chamfer OD here on the manifold. And the O-ring that's on top of the nipple is actually going to seal up against that surface. The tighter this nut gets screwed on, the stronger the seal is between the PEX connection and the manifold, creating a nice tight fix. Let's take a look at a cross-section of the manifold that we just looked at here. Some detail. Here are those 2 O-rings that we just referred to. Now this is after the PEX has been assembled to the manifold. Right, so those are 2 O-rings. In green would signify the PEX. Now you can see the PEX now has been deformed by squeezing the bushing against the PEX we've actually deformed it, caused a nice tight surface here with the knurled edges. Very good surface on the O-rings. Okay. Another thing is that, unlike some other manufacturers, we created an insulation barrier here between the PEX and the brass fitting. Well, why is that? Well, aluminum and brass are dissimilar materials, and we don't want to have any onset of galvanic corrosion happening as a result of not having any insulation between those two dissimilar metals. Another design detail unique to Caleffi is the shape of the port is not cylindrical, it's actually V-shaped or Venturi-shaped. We take a little bit more effort and expense in machining our fittings because as fluid is coming down here going out to our zones, if we had instead just machined a cylindrical hole in these fittings, as fluid goes around the right edges created by that cylinder, what does that mean? Well, in hydronics, anything going around 90 degrees real quickly is going to do noise and pressure drop. So we're able to minimize any type of pressure drop by having these conical type shapes to our fittings. And then lastly, as we screw on that nut here, we compress that bushing, which also compresses up against those O-rings. So the tighter the nut, the tighter you make the nut, the better the seal. And that can contrast against some other competitors out there who do not seal up against a chamfer, but actually create an interference on the ID of the port. So no matter how tight the contractor tries to tighten it up, it doesn't change the ability for the compression fitting to seal. Okay, let's take a look at the dimensions of the various universal fittings that we have for PEX. On top here is the design detail that we looked at. This is the design for PEX, straight PEX. And then down below is our design for PEX aluminum PEX. A little bit different. Similarly, two O-rings positioned a little bit differently on the nipple. But the biggest difference is we use a metal bushing because when you're squeezing against PEX aluminum PEX, it's a very stiff pipe. And so by having a metal bushing, we're capable of actually deforming it and causing a very tight grip on the nipple and preventing any kind of pull-off. Lastly, before we leave the slide, we also have a 5/16 inch PEX fitting. And this is used uniquely in fast-track type of radiant panels offered by 2 or 3 major brands in the marketplace. So if you are looking for a solution for that product using the Caleffi manifolds, we have the fitting for you specifically for 5/16. Okay, let's take a look at our families of manifolds. We have 3. The bread and butter is the 668 S1 series manifold. It's rated at 180 degrees and 200 degrees peak, so high temperature rated. The loop flow coefficient, both the supply and return loops combined, is 1.23. This is combined flow coefficient. Individually, the loop flow coefficient is lesser so, but this makes it easier to calculate pressure drops through a loop. So we add that in our technical information. Our 663 series is our next line, very similar product line. However, it's rated for 210 degrees and higher flow coefficient, less pressure drop through the loops. This would be used for snow melt and applications where you want to have more flow, and the way you balance is a little bit different, and we'll get into that in a few slides as well. And then lastly, our 592 series, which is 210 degree rated and doesn't have any valving going on. It's pretty much straight through, straight back, oftentimes a solution for high flow applications such as snow melt. All of the manifolds that get shipped out from us are fully assembled and pressure tested. In fact, here's a shot of one of our assemblers, our proud veteran Ralph. We caught Ralph to try to get him to smile on a Monday. We probably should have waited until Friday before we took this photograph. That's as much as we could get out of him on that day. But Ralph does a great job with our assembly process and making sure those get packed up, pressure decay tested, and shipped out in a high-quality fashion. Close look at the features of our 668 S1. We'll start off at the upper left-hand corner here. You have a choice of getting the manifolds in either 1 inch or 1 1/4 inch sizes. Okay. Working our way right, our balancing is done, and our flow gauges are all on the supply side of our manifold. And we'll get into that in another slide. So you actually do your flow adjustments with this. Air vents on both the supply and return side, not just air vents, but automatic air vents. And on each of the air vent bottoms, we have the fill and drain valves, not a barb, but a true hosed connection for filling and draining conveniently. You can see in red and blue here, zone identifiers, bath, laundry, family room. I think the only thing we don't have is the manly man room. I think we got a wild card one in case you want to write that in. And on the return side of our manifolds, we have close-off valves, and we'll show a close-up of that. These valves, because we're not balancing on the return side, we're balancing on the supply side, these simply act as shut-off valves, and when you're in operation, they're fully open. So they're typically fully open or fully closed. And then lastly, you can see temperature gauge ports available on both the supply and return side in the event that you want to add an accessory temperature gauge, which we offer as well. Now, before I leave this slide, you notice that the brackets are kind of skewed. That isn't because Ralph stayed out too late the night before. It's by design, and by having that skewed bracketry, it allows us to have a nice up and down vertical, clean installation as it pertains to the supply and return PEX. Okay, it makes it very convenient to run the PEX up through the manifold. And so it's that skewed angle combined with the unique design from a cross-section of our manifolds that creates a very compact up and down orientation. While we're on this slide here, another feature of Caleffi manifolds is you notice they have kind of an undulating, cross-sectional look. All right, and this white area would indicate where the valving is done. So we basically, in this picture, just sliced open the manifold and showed you what's on the inside. And you can see here, B plus C equals A. The cross-sectional area of B and C equals A. So as flow comes in from the left side, goes around the porting, and through to the next, the cross-sectional area never changes. And as a result, there isn't any pressure drop. If this were an extruded manifold, every time you'd squeeze around those portings, you would create a bottleneck, a pressure drop, and all things being equal, your flow in this port would be more so than your flow in this port. So we take that variable out of the equation with our design. Here's another shot of a different shot of the manifold assembly. This contractor now is closing off the shutoff valve here, and here's the detail of that shutoff valve. Up on top, this is the white knob that you see here. Okay, and if he were to unscrew that white knob, perhaps doing that to screw on a zone valve, as he does it, you can see down in red here, this is actually a spring and compression that's pushing up on the stem. So as you spun that knob off, the stem comes off its seat, and now the valve is fully opened. Okay, with that knob on there, and he screws it clockwise, it actually pushes that stem down and seals it off. And that would be typically what he would do in the case of filling and purging his lines as he commissions the system. Here's a shot of a contractor now on the supply side of the manifold, and this gives you an indication of how the balancing is done. Basically, these white caps pop off, turn them upside down, they turn into a wrench, and he just basically adjusts the flow to his desired value for each of his loops. How does he do that? Well, right out of our installation manual, lift, twist, and go. Very simple. And on the right-hand side now is the cross-section of our valves that we do the balancing on. And for the sake of simplicity, basically the more flow we have through a manifold, this pin right here with this little flat head right here gets pulled down further into the venturi. And as it does, the red disc up here would show the corresponding flow rate. Okay? And before we leave that manifold, here's a shot from Energy Products up in Minnesota using the S1 manifolds on a nice clean system here. I'm not sure if this is a photograph or a rendering, but it might be a combination of both, but pretty clean lines. Okay, the second of the three families is a 663 family, similarly available in 1 inch or 1 1/4 inch. All right, Now the differences are down here on the supply side of the manifold. We don't have the visual flow gauges here. The balancing is done by way of a more traditional means, shown in this next graph, and using an L wrench, and just basically as a function of turns, it results in a flow coefficient that is predetermined. So with the valve turned all the way down, there's no flow, and by turning it 1.5 turns, you crack it open, and the flow coefficient is 0.25, and so on and so forth, to the point where if you open it to 4 turns, the flow coefficient is 3.0, and fully open 3.2. So if you know what your pump head is, and you know the pressure drop through your loop, given the CV here, you can calculate the flow rate based on turns. A little bit more work. Some people do this. We provide that option. And here's a shot of a contractor with that particular manifold and the 663 manifold. And here's a nice way you can see kind of the straight up and down orientation. Our supply loops go down and the returns come back. They nestle behind for a nice, clean, tight fit. This doesn't show it going into a wall because there's actually space between the back of these unibrackets and the wall here, but if it were going into a 2x4 wall, it would fit very nicely. And then our last family, the 592, available anywhere from 2 to 8 loops, shipped out, fully assembled from us, and these are only available in 1.25 inch sizes, higher flow sizes. Here's a shot of a contractor who's actually interesting. He had a closet that housed a manifold with quite a bit of stuff going on there, and he cleaned it up using the 592 series. Good job. Okay, here's a close-up of the supply side of our S1 manifold again, and I want to pay attention over here to the air vent. All right. With our manifold assemblies, we send caps to be used for pressure testing the system, and we always want to caution, once those caps are used for pressure testing, make sure they're removed and the normal cap gets put in its place. Otherwise, we get a phone call and we find out that somebody didn't remove the caps and replace them. Now let's talk about that air vent design, and right here is a cross-section of the Caleffi air vents, and like many other air vents, inside is a float. In blue here, light blue, is the water level inside of that air vent, and white would be the air. In this mode, this would be a closed air vent. There's nothing happening. Now if air got caught and captured here, the water level would drop, the float would drop with it, pulling this lever and opening up this little needle valve. And because the system's under pressure, the air then would just basically squirt out, get pushed out, not squirt out, pushed out, goes up through here. And these little orange wafers here, the flow would go through there and out this little slot. Okay, what are these little orange wafers? Those little orange wafers are a redundant backup. They're hygroscopic discs. And this is what they look like. Hot Rod Roar has put them on a paper clip to give you an idea. The top one is one of those discs in a dry state, and the bottom one is one of those discs in a damp state. How they work is as soon as they see moisture, they actually swell up very quickly to 50% their size, as you can see here. And as they swell up, basically they seal off any further passage. So in the event that perhaps you get a momentarily piece of debris or something here, and water would just want to otherwise come up through here, the hygroscopic air vents would basically swell up and prevent that water from passage. Now, other specs will sometimes call for, on manifolds, a drain valve or something to be used. We just kind of reinvented the wheel here, not reinvented the wheel here, but took care of that problem by way of these hygroscopic air discs. Other accessories that we offer, manifold cabinets, anywhere from 16-inch wide up to 48 inches wide, capable of handling, as you can see here, the corresponding number of ports on a manifold. So a 3-port manifold would go into a 16-inch cabinet, up to 6 ports, 24-inch, so on and so forth. These are high-quality powder-coated cabinets, 18 gauge with folded seams, and the depth is conveniently adjustable, anywhere from 4 3/8 to 5 1/2 inches. So let's take a look at what a contractor's done with the cabinet. Here's a nice clean look. He's installed this manifold assembly into a 2x4 space, fold it out to make room for the drywall thickness. Nice clean lines here on this contractor's job. Another contractor with a cabinet. Good work, Hydronic Incorporated. And to see what the cabinet looks like with the cover on is a shot from our offices. In fact, looks very nice and clean. And by the way, that's our head of customer service, Naomi, in case you haven't met her before. Now, on some of our manifolds, we don't have built-in flow meters or flow gauges, and for those that want to use meters nonetheless, we have an accessory line of flow meters, 5 different part numbers. The first 3, the gauges are in scales of liters per minute, 1 to 4 liters per minute, 1 to 3.5 liters per minute, 0.6 to 2.4, etc., and also gallons per minute. Now, we have a very unique design on our 1 to 4 liters per minute flow meter, and this solves the problem with flow meters clouding up. Actually, it's a glass within a glass, hermetically sealed scale. So over time, if you wanted to go back and look at what the flow rate is, the contractor simply turns this knurl right here. A clean scale comes into view. He sees the flow rate and then sets it back. A very unique feature for our flow gauges. Here's a shot of the flow gauges actually on our facility here in Milwaukee. What we wanted to show here is this is a 1 to 4 gallon per minute flow gauge. Now, interesting, each of these loops, these aren't balanced. There's no valving going on, but they're reading a little bit different. Off to the right here, we can see that this flow gauge has 3 gallons per minute going through it. The one in the middle about 3.5, and this one about 3 1/3. Well, each of these PEX lines is a little bit different in length, and so you can see how the effect of loop lengths causes a little bit more pressure drop, and as a result, differing flow rates in each of these circuits. By the way, these are all chewed up here. We take these out and take them off for various testing, so don't let that concern you, the chewed up look of those gauges. Here's another shot of the gauges. Let's take a close look here, courtesy from our friends up in Canada. Flow gauge is getting assembled onto one of the Caleffi manifolds. Another very convenient accessory is snap-on thermometers. These thermometers can snap right onto the PEX, 3/8 inch, 1/2 inch, 5/8, or PEX aluminum PEX. It's our part number 6759000A, as you can see there. And here is a rendering of how those would go on. What these are really useful for is quick heat delivery estimation. So if, for example, the thermometer on the left-hand side was snapped onto our supply side, okay, PEX, and coming off the return side, this thermometer, and they were reading these levels, this gives us a delta T, these 2 different thermometers. Our flow indicator gives us the flow rate, and as long as we have delta T and flow rate, we can calculate very easily the amount of BTUs getting emitted into that zone using this formula. 105 degrees, which is the temperature of our supply side. Okay, you can see here. 90 degrees is the temperature of our return side, times 2 gallons per minute, our flow rate through that circuit, and multiplied by a simple factor of 500. So at a glance, we can see, without fancy instrumentation, that we're delivering about 15,000 BTUs per hour into that zone. That's a very handy, inexpensive feature, and these little snap-on thermometers come with a little bit of a heat grease that gets put between them and the PEX to maximize the heat transfer between the thermometer and the tubing. Another feature of our products, our accessories, is our telestats or our zone valves. Here's a contractor operating our manually opening telestats. We have them both as standard designs as well as this manual open version called twist top. Now, the twist top is very handy, and here's a cross-section look at what those twist tops and all of our actuators look like. It's basically a heat motor, and as current is applied to a resistor, if you will, it heats up, the heat motor expands, and basically causes the actuator to open and close. So that's basically the essence of how it works. The cool thing about these is the twist open feature. When you twist them open, if they're the version that also contains an in switch, it causes the in switch to close, so you can check electrically if your system's working, sending a signal over to your relay or what have you. And if the contractor forgets to close the twist top, no problem. As soon as they see power for the first time, they reset on their own. So they're dummy-proof, or foolproof, if you will. And also, another feature on these type of actuators is visually you can see whether or not there is flow going through the telestat. And that's very convenient. And here you can see a shot of that. Here's 4 telestats, and the ones on the left are on, indicating flow going through them, and the ones on the right are not calling for any heat. Another nice feature of these telestats having the manual open feature is a contractor can pre-assemble the manifolds onto the manifold, put it onto the wall, and if the electrician hasn't been in to wire from the transformer down to the actuators, no problem. He doesn't have to worry about turning on a thermostat to activate the zone. He just twists it open. So it saves a lot of time and saves on sometimes scraped knuckles, as some contractors will call these, the knuckle scraper savers. All right, here's one of those actuators, actually. You can tell it's a Caleffi actuator because the telltale Caleffi green box is off to the right. This contractor is using these actuators on a manifold that we don't make. In some cases, we'll make them available for a competitive line of actuators. If you're interested in that, give your Caleffi rep a call or call our offices because the design is a little bit different than the actuator design is a little bit different for a competitive line. Okay, temperature gauges. Another accessory. Here's a shot of a manifold with the supply and return temperature gauges, which might be of value to you in your future jobs. Differential pressure bypass valves, another feature. Here's a shot off to the left of a manifold assembly. You can see the differential pressure bypass valve here. And so how does the contractor install that? These are all accessories that are field installed. So basically, as indicated by step 1 here, the bottom field port gets screwed off, and the bottom air vent gets screwed off, and basically it just screws right into those open ports in just a matter of minutes. Now the manifold assembly has a convenient bypass. Now these bypasses are fixed opening pressures of 3.6 psi, or crack pressure of 3.6 psi. Okay, so why 3.6 psi? Well, we can get an idea of why at that level if we just look at a typical example. This is the hydraulic characteristics of a 6-port manifold, 6 loops. Okay, as evidenced in here by blue. All right, 6 loops, and driven by a pump with a flow curve characteristic as indicated by red here. And the scale in pressure is PSI, red, 16 PSI, and flow rate up to 14 GPM. Now this is a very vertical curve, and this is a pretty big pump. Probably too big of a pump for the job, but we wanted to use this as an illustration. So when all zones are calling for heat, and all ports are having flow sent through them, that would be this state right here, shown by my cursor. All right. At that state, it's 9 gallons per minute going through the manifold. Okay. There's 6 ports, so if you take 9 divided by 6, each of those loops is getting 1.5 gallons per minute per branch. Okay. But as the various zones start turning off as they are satisfied for heat, and we have 1 zone left, then how much flow is going through that zone? Well, in this case, if you take that vertical drop, and you can see now it's 5 gallons per minute with only 1 zone open, there's 5 gallons per minute going through that loop. Now, that could be some problems because perhaps there's going to be noise or possible erosion. And to rectify that, let's put the Caleffi differential pressure bypass valve on that manifold. Now remember, it's got a 3.6 psi opening pressure. So if we go over to the right here up to 3.6 psi and come across here, we can see that after the first zone valve is turned off, from that point forward, as further zones turn off, rather than following the pump curve this way, it actually flattens the pump curve here to the point where when only 1 zone is open, it's only 3 gallons per minute. Okay? So basically, we're bypassing flow rather than sending too much flow through the PEX. Now, is 3 gallons per minute okay? Well, it depends on what size PEX we're running. And so the rule of thumb with PEX is that you don't want to exceed 4 feet per second. And so the gallons per minute that equate to 4 feet per second is shown here as a function of the tubing size. So in that previous example, as long as we had 5/8 or 3/4 inch PEX, we had no problem running 3.3 gallons per minute through there. But if we were running the more popular 1/2 inch PEX, we would be exceeding the recommended flow rate. We'd have noise probably issues. Now we could have fixed that by having a pump with less of a head on it, and that in combination with the Caleffi differential pressure bypass valve would have given a very nice flat curve here. Or another solution is to have a variable differential pressure bypass valve. We didn't have a Caleffi shot of it, and in the interest of time we found this one, and this was a very nice shot, even though it's not our manifold, but it looks like a Caleffi differential pressure bypass valve, which you can see there by the red circle. So what's happening here is that the bypass loop here is as such. So now the contractor can take the variable differential pressure bypass valve, set it to the appropriate setting, and accomplish the same task. So different ways of skinning the cat, if you will. With the onset of, or the popularity of delta P pumps or variable speed pumps becoming more and more commonplace, as evidenced by Grundfos's Alpha and the Velo, and now the B&G or IT&T lane pumps, the differential pressure bypass issue will be a thing of the past because the circulators are capable of detecting would-be pressure changes and changing the flow rate accordingly to always deliver the same amount of flow in the open circuits. And so how does it, what happens basically, looking back at a pump curve here, basically creates a nice flat curve so that regardless of how many zones are open or closed, the design amount of flow goes through those circuits. Let's move on to more enhanced manifolds. These are temperature regulating manifolds. We have two families, the 172 series family and the 171 series family. They're the same family with the difference. On the left-hand side, what we've done is we've taken a pump and a mixing valve assembly, in this case a mixing valve that is fixed temperature, so it's always going to deliver the set temperature, whatever you dial into. So perhaps you have a straightforward radiant zone that you want to deliver 105 degrees. Set this to 105 degrees, and now you have the ability to accomplish that with the Caleffi temperature regulating manifold solution on the left-hand side here. On the right-hand side here, instead of having a fixed temperature manifold, we have a motorized actuator, actually 24 volt, which can be controlled by any floating point control and modulating, say put on outdoor reset. And so here's a depiction of both of those manifolds. It's a very complicated schematic, apologies for that, but basically what we have here is a pump that's delivering high temperature fluid. It tees out. One side it goes to a manifold assembly that is motorized and is hooked to a reset controller driven by outdoor reset. And on the left-hand side, a more simple radiant system driven by the thermostatic mixing valve or fixed temperature manifold. Typical applications for this line of products. Another accessory we have, how many times have you seen a contractor with a Craftsman wrench with the inch drilled out so you can conveniently tighten up PEX fittings? Well, you don't have to worry about that anymore because Caleffi will have a wrench that accomplishes that has the opening and the right sizes for the nuts on the radiant manifolds. This is a very blurry picture. Why should you know this guy? Well, you probably don't maybe not know the guy, but maybe why should you know this company that he heads? This is Rath Associates, the Caleffi 2009 Rep of the Year. They're in New York. They cover the metropolitan New York City for Caleffi. And I think everyone probably on this call knows that New York is a tough market, very competitive market. Whether you're selling bananas, life insurance, appliances, or cars, it's a very, very competitive market. Does Rath sell many Caleffi manifolds? Yes, and they sell a lot of them in the competitive New York market. Lastly, last shot of our manifolds, courtesy of Able Distributors. They are depicting the versatility of the Caleffi manifolds, capable of operating with and without our telestats, standard telestats, twist-top telestats, all the different accessories available, different types of PEX, whether it's the Rayhouse or the Wupanors or any other ASTM high-quality PEX line out there, compatible with all of them. There was a contractor, a well-noted contractor out east, but didn't get a chance to get his permission for this webinar, once coined the Caleffi manifolds the Maserati of manifolds. We actually toyed with the idea of perhaps tying that name as a subname for our manifolds, and we thought otherwise because of two reasons. Number one, there would be a major licensing issue, and number two, Maserati connotates a very expensive product. And the Caleffi manifolds, even though they're highly featured and highly engineered, are very competitively priced. So we dropped the idea, but sometimes you hear the product line referred to as the Maserati line. Finishing up here, we have a number of supporting literature documents, cell sheets as an example, on the manifolds. All of our cell sheets give a depiction of the features and benefits of the product and also comparison to competitive products. So if you're interested, contact your rep or Caleffi for that product. For more of the engineered types, we have technical brochures and engineering data sheets online for your convenience. And then lastly, our Caleffi manifolds, as well as all of our Caleffi products, are compliant with the Buy America Act. So if there's any issues from a government contract standpoint requiring Buy American, everything that we market here in the United States complies with the Act. Thank you very much for your attention. We appreciate dialing in and learning about